Hey everyone, and welcome. Today we're going to tackle one of the most powerful tools out there for developers, Docker, and we're going to take it step by step from zero all the way to packaging and sharing your very own app. So, you ready? Let's jump right in.
Okay, so first things first, let's get a bird's eye view of how this whole thing works. It's really just a few key pieces working together. Now you'll mostly be hanging out in the command line interface, the CLI. That's just your terminal, where you type in the commands. When you type a command, it gets sent over to the Docker daemon. Think of the daemon as the big brain, the engine in the background that does all the heavy lifting, building, running, you name it. And to make our lives way easier, there's also Docker Desktop. That's the nice clickable app you see here, the GUI. It helps you see and manage everything visually, which is super helpful when you're starting out.
So here's the game plan for today. First, we'll cover what Docker actually is and get it set up. Then, we'll dive right in and run our very first container. After that, we'll get into managing everything, understand how images are put together, and then, the best part, we'll build and share our own custom image. Let's get to it.
All right, part one. Let's get this thing installed and ready to roll on your machine. Okay, first up, you're going to want to download and install Docker Desktop for your system, whether you're on Mac, Windows, or Linux. While that's downloading, pop over to hub.docker.com and sign up for a free account. Now, this is super important. Once it's installed, make sure you log in to the Docker Desktop app with the same account you just created on Docker Hub. This links them together, and trust me, you'll need that connection later when we want to share our stuff.
All right, once that's all installed, go ahead and open up your terminal or command line. The easiest way to check if everything's good to go is to just type docker-version and hit enter. If a version number pops up, just like you see here, boom, you're in business. We're ready for the fun part.
Okay, installation is done. Let's move on to section 2. This is where you get that aha moment. It's time to run your very first Docker container. So we're going to start with a command called docker pull. Now, what's an image? Think of it like a blueprint or maybe a recipe for an application. It has everything needed to run that piece of software. So when we type docker pull hello world, we're telling Docker, hey, go to your big public library, which is Docker Hub. Find me the blueprint for hello world and download it to my computer.
Okay, so we've got the blueprint. Now let's actually build something with it. The docker run command does exactly that. It takes the image and spins up a live running instance. And that running instance, that's what we call a container. And you can see right here in the output, when we run the hello world image, it just runs a tiny program that prints this message. It's basically Docker's way of saying, yep, everything's working.
And look, we have proof. You can see that new container in two places. Over on the left, there it is, nice and neat in the Docker Desktop app. And on the right, if you're in the terminal, just type docker ps-a and you'll see it listed there too. Same info, just two different ways of looking at it.
So, awesome, you've run a container. Now what? Well, now we've got to learn how to manage these things. Let's get into the core commands you'll be using pretty much every single day.
These right here are the real workhorses of Docker. We've already met pull for downloading images and run for creating and starting a container from an image. Docker Images is simple. It just lists all the blueprints you've downloaded. Then you have stop and start to control existing containers. And when you're done, you'll use Docker RM to get rid of containers and Docker RMI to get rid of the images themselves. We'll circle back to that last one in just a second.
Okay, this next one trips up everyone when they're starting out, so listen up. If you just type docker ps, you're only going to see containers that are currently running. Our hello world container, it runs, prints its message, and immediately stops, so it won't show up with just docker ps. You have to add that little -a flag, which stands for all, to see everything, including all the containers that have already stopped.
And here's another super important one, run versus start. Remember this, every single time you use Docker Run, you are creating a brand new container from scratch, using the image as a blueprint. So if you type Docker Run hello world 5 times, you'll end up with 5 different separate containers. But if you just want to restart one of those containers that's already stopped, you use Docker Start and give it the container's name or ID. It's way more efficient.
Okay, so what happens when you want to clean things up and get rid of an image? Well, you can't just delete an image if there's a container using it. Even a stopped one, Docker will just give you an error. There's a specific order you have to follow. First, make sure any containers using the image are stopped. Second, you have to remove the container itself using Docker RM. And only then, once nothing is using that image anymore, can you finally remove the image with Docker RMI.
All right, now we're getting to the really cool stuff, the magic behind why Docker is so fast and efficient. We're going to pull back the curtain on two key concepts, image layers and port binding.
So try not to think of a Docker image as one big single file. It's actually more like a stack of layers, almost like those transparent sheets you'd use on an old overhead projector. Each layer is a set of instructions like install this program or add this file. And all those base layers are read-only. They can't be changed. When you start a container, Docker just slaps a thin, writable layer right on top, and that's where all your app's changes happen.
And this whole layer thing isn't just some abstract idea. You can actually see it in action. When you pull a bigger image, like MySQL, look at the terminal. You can see Docker downloading each file system layer one by one. And here's the genius part. If you go and download another image that happens to use some of those same base layers, say they're both built on Linux, Docker's smart enough to not download them again. It just reuses the layers it already has. It's incredibly efficient and saves a ton of time and disk space.
Okay, next up, port binding. So remember how we said a container is its own isolated world? It's like a tiny computer running inside your main computer. So if you have a web server or a database running inside that container, how on earth do you talk to it from your web browser or your code? The answer is port binding. It's basically like digging a little tunnel from the outside world, a port on your machine, directly to a port inside the isolated container.
And here's what that looks like in a real command. When you're doing a Docker run, you just add the -p flag. The format is always host port first, then a colon, then container port. So in this example, -p 8080:3306 tells Docker, hey, anything that comes knocking on port 8080 of my computer, I want you to forward it directly to port 3306 inside the container. And that's exactly how we'd connect to that MySQL database.
All right, this brings us to the grand finale, and honestly, the most powerful part of all this. Up until now, we've just been a consumer, right? We've been using images that other people built. Now, we're going to switch hats and become the creator. It's time to package up our own application.
The whole workflow, from your code to a shareable app, really breaks down into these 5 simple steps. First, you've got your app code. Second, you write a special recipe file called the Docker file. Third, you use Docker build to bake that recipe into an image. Fourth, you give it a proper name tag so Docker Hub knows where it belongs. And fifth, you use Docker push to send it up to the cloud for anyone to use.
Okay, the Docker file. This little text file is the absolute heart of building your own image. It's just a plain text file, literally named Docker file, with no extension. Let's quickly walk through this super simple one for a Python app. From Python says, hey, we're starting with the official Python image as our base. Work their app is like saying cd into a folder named app inside the container. Copy.app means copy everything from my current directory on my computer into that app folder inside the container. And finally, cmd tells Docker what command to run automatically when someone starts a container from this image.
And when you follow those steps, build, tag, and push, this is what you get. Your very own custom image sitting right there in your Docker Hub repository, ready for you, your team, or anyone in the world to pull down and run. Now, quick pro tip, because this gets everybody. The #1 mistake is forgetting to tag your image correctly before you push. You have to include your username. So if you build an image called My App, you have to retag it as your username /My App. If you don't, Docker won't know where to push it.
So there you have it. In just a handful of minutes, we've gone from a fresh install all the way to building and sharing our own custom application. What you've just learned is a truly foundational skill in modern software development. So really, the only question left is, what are you going to build next?